Good morning, everybody. Here is a Schlatter relay board. Set our meter to diode mode. We're going to test these diodes over here. Let's see if I can do this without getting in the way. 0.575 diode drop, that's good. 0.588 volt diode drop, that's good. 0.564, 0.584, get on there. 0.579. Now this one's already been replaced. You can see it's up in the air a little bit. 0.581. Somebody has replaced that one already. Here's the last one. Oh, look at that. That's bad. Get on there. That's a dead short right there. There's the problem with this board. We're going to have to replace that diode. Alright, let me get it off the board and I'll put a new one in there. This board will be good to go. Thank y'all for stopping by. That was an easy one. Okay. Have a good day, all. We'll see you next time. Hello all! Now here's one page of my drawings of the Schlatter relay board model 4-406140. Many times, many times you will get a board into the shop. You won't have no drawings, no prints. You won't even know what that board's supposed to do. And that's okay. That happens 99.9% of the time. So I make my drawings, and then I'll poke around on the board until I find something bad. In this case, we got lucky. We found a shorted diode. Now here is the X1 connector that we connected to test that board. We energized that relay. I put 24 volts DC up here to point A through this forward bias diode. Then I put 24 volts DC down here on terminal 1. Up here was terminal 5 start. Terminal 1 I applied 24 volts DC and turned on the gate of that MOSFET. We'll get there in just a second. Hold on. The gate of the MOSFET, when turned on, energized the K1 relay and closed these contacts. Then I put my meter across this contact, the common contact, and the normally closed contact, and I measured for contact resistance. And down here I did the same thing. I measured for contact resistance, and I wanted very close to 0 ohms right there when that relay was energized. When that relay was energized, this LED, this red LED turned on right here because we had plus 24 volts into the gate of the MOSFET that turned on this K1 relay. The contact closed, and that 24 volts flowed up through the common and normally open contact, which was now closed, through the 2.7 kilo ohm resistor and the LED one right here back to ground. Now ground on the X1 connector is on terminals 2 and 4. Now here's where it gets a hair bit interesting. Let's put up the second page of my drawings. Down here is the X1 connector connected to ground on terminals 2 and 4. All of the voltages are referenced to those 2 points right there. 2 to ground and 4 to ground. When I apply 24 volts DC, let's go back. Here at point B at X1, terminal 1, that 24 volts drives into the gate through this resistor right here and turns on that MOSFET. When that MOSFET is turned on, let's go back again. The 24 volts that I applied to X1 terminal 5 at point A, up here, 24 volts DC, flows through the K1 relay through the MOSFET, part number BSS89, to ground. This ground right here, energizing that K1 relay. There's a couple of interesting things about this circuit. We have a capacitor right here, C1, of 22 microfarad at 50 volts. When I apply the 24 volts through R3, it charges up this capacitor, and at the same time it turns on this MOSFET, which allows current to flow through that relay coil to ground, energizing that relay. When I remove the 24 volts DC at point B right here, let's go back again. Point B being X1, terminal 1. When I remove that voltage right there, this capacitor will hold the charge on the gate, keeping that MOSFET turned on until we discharge that capacitor through this 220 kilo ohm resistor right here to ground, providing a timing function. So we charge up by applying 24 volts to this point right here, turning on the MOSFET, that enhancement mode MOSFET, turning on the relay. When we remove the 24 volts right here, that MOSFET will be maintained on until this capacitor discharges through that 220k ohm resistor right there, R2, giving us a little bit of a delay right here. Isn't that amazing? All right, folks. Hope y'all enjoyed that video, and I hope y'all's doing alright out there. We're doing okay here. I think we're past our monsoon season. We have had rain and rain and rain, but today is a sunny day. The birds have come back onto the bird feeders, and everything is turning green again. Shoo-wee. For too long we'll be in winter again. I ain't got to say this, but take care of your families. They're most important.